Welcome to Lahari tutorial for colorful chemistry. In a previous video, we have learned some nomenclature rules for naming a coordination compounds. Okay, now let us solve some problems here. Okay, already I have solved one problem. Okay, that is potassium tetracyanonickelate 0. Okay, as per rules, first we have to name the cation. Here in the complex, plus we have to put a charge on the atom and the sphere. Okay, here the potassium charge is +1. Here there are 4 potassium, so that +4, and here it is a -4. So first I have written here potassium. So how many ligands? 4 ligand, that is tetra. So the name of the ligand is cyano. Okay, cyanide, but the negative ligand ends with a suffix O, so that cyano or cyanido. So then the central metal is nickel. Here the complex is negative, so that here we have to ends with the metal name ATE, so that it becomes a nickelate. Now let us solve oxidation state of the central metal. Let us consider X plus, here the coordination number is 4, that is 4 into -1 is equal to the charge on the sphere. Okay, that is -4. Okay, after calculating, what you will get? X is equal to 0. So the oxidation state will be 0. Now what is the name of the complex? Potassium tetracyanonickelate. Now let us solve this example. Here first we have to dissociate this complex. So then we will get a charge on a particular simple ion and the complex ion. Here we have a simple anion. The charge of this chloride is -1. There are 4 chloride present, it becomes a -4. Now the complex becomes a +4. So according to the rules, first we have to name the cation. Okay, so the cation is here complex cation. So in the coordination sphere, first we have to name the ligand. Okay, the name of the ligand is amine. It is one of a neutral ligand, so that we have to name as such a molecule. How many ligand here present? 6. So that hexaamine. Now it is complete. Then we have to go for a central metal. Which is central metal present here? Platinum. Here the sphere is positive, so we have to name the metal as such a name of the metal, so that here we have to calculate the oxidation state of a central metal. X plus 6 into 0, because ammonia is a neutral ligand, is equal to +4. Now X equal to +4. So the oxidation state of a central metal is +4. Now this part is complete. Okay, so here the last is the simple ion. It is a chloride. Yes, the name of the complex is hexamine platinum 4 chloride. Hope you understand. Okay, the next is, here again we have a simple cation and a complex anion. Now the charge will be +2 and -2. Yes, write the simple cation potassium. Okay, so now how many ligands present here? So already have told you the central metal place is always fixed. Okay, it is located at a corner of the coordination sphere. So it is the central metal. So how many ligands present here? There are 2 ligands present. The one is cyanide and another one is a nitrosyl. Here nitrosyl is a neutral ligand, the cyanide is a negative ligand. So as per the rules, we have to name alphabetically. The ligands are named alphabetically. So first will come the cyanide. Okay, how many cyanide present here? 5. Penta, cyano, nitrosyl. Okay, the metal. Okay, before going to the metal, we have to calculate oxidation state, that is X plus 5 into -1 plus 0 is equal to -2. Here X is oxidation state of central metal, 5 is the ligand. Okay, the cyanide ligand. How many cyanide ligand are present? 5. 5 into the charge of the cyanide is -1 plus 0 is equal to -2. X minus 5 minus 2. The value of X becomes +3. Okay, the oxidation state of the central metal is +3. So we can write as So the another one thing is the complex is negative, so that the name of the metal ends with the ATE. Ferrate oxidation state will be 3. Now the name of the complex becomes potassium pentacyano-nitrosyl ferrate 3. Okay, the next example. Again here also there is a simple cation and complex anion. +3 -3. So write potassium. Okay, what about the ligand here? Yes, it is a oxalate. Trioxalato. So the charge will be -3. Now let us calculate the oxidation state. X plus 3 into -1 is equal to -3. X plus -3 is equal to -3. Okay, the charge becomes, here X value become 0. What will be the potassium trioxalate to ferrate, oxidation state becomes 0. Okay, next example. So here we have complex cation, simple anion. So let's name first the cation, that is a complex cation. Here the name of the ligand is aqua. How many present? How many ligands? 6 ligands. So that hexa aqua. The metal is chromium. Okay, let us calculate the oxidation state. So simply here we can calculate like, okay, it has a -3 charge, so it is a plus. The sum of charges on central metal and a ligand is equal to the charge on a sphere. The charge of the ligand here 0. The sum of the charges on a central metal and the ligand, so it becomes plus 3. So it is also simple way to calculate the oxidation state of a central metal. So it becomes a 3. Hexa aqua chromium 3. The last is chloride. Okay, the next example. So the nitrate has a -1 charge, so it has a +1. The charge on a ligand, it is a 0, and here it is -2. So the charge on a complex central metal will be +3. So how many ligands? There are two types of ligands. The one is aqua and another one is chloro. First we have to take tetra aqua dichlorochromium, because it is a means the complex ion is positive, that is a cation. So that we have to name a central metal as such a name of a molecule. Chromium 3 nitrate. Okay, in some cases, if they are given in a words, we have to write the formula. Here first we have to identify sodium. Sodium is not a ligand or a central metal. Here it is a one of a simple cation. Okay, now into bracket. Okay, in this, which is the central metal? Borate, B. Then what about the ligand? Nitrito, that is NO2. So the thing is, we have to add the number of ligands. See here, tetra nitrito charge is -1, so it becomes a -4. So what about the charge on the sphere? It becomes a -1, so it is plus. Okay, this is the formula of this one, sodium tetranitrito borate. Similarly, here tetracarbonyl iron. So the oxidation state is 0. Okay, here there is no, it is a one of a neutral complex, so that directly I will put a coordination sphere. So tetracarbonyl iron. Here the central metal is iron and the ligand is carbonyl. How many ligands present here? Tetra, 4. So the iron charge is 0. It is one of a neutral ligand, so that the charge of this ligand will be 0. It is a one of a neutral complex. Similarly, potassium dicyanoargentate. Here potassium, okay, out of the sphere, potassium is a simple cation. Okay, argentate is nothing but a silver metal. The ligand is